All right, so all of chapter 8 so far, okay, we have talked about rational equations, having that ability to add them, subtract them, multiply them, divide them, simplify them, and now we're going to look at using all those components to help us solve them, okay? So when one or both sides of an equation contains a rational expression, we can eliminate the need for the rationals or fractions by multiplying every numerator by the least common denominator. Okay, the numerator. So that's going to be the one that we're going to be using the most. Simply just multiplying everything on both sides by the least common denominator. Okay. The second one, if our equation is a proportion, which is defined as a rational set that is equal to another rational, right? So like for instance, if we're saying like 1/2 equals 2/4, right? That is a proportion. We can simplify or simply multiply each rational by both denominators. So what we're saying here is we can cross multiply. Right? So we can cross multiply and we should get the same thing on both sides, right? Equal. Okay, so like looking at the first example, all right, the biggest thing to recognize here, what is the solution to the rational equation 6 over x plus x over 2 equals 4? Okay, the least common denominator between all three of those terms is 2x. Okay, so notice in the first step, we're going to multiply everything on both sides by 2x, and we see that our x's are going to cancel out in the first term and be left with 12. The 2's are going to cancel out in the second term and be left with x times x, or x squared. And then 2x times 4 is going to give me that 8x. And all we have to do now is solve for that quadratic. Okay? So make sure you guys go through. The goal here is to get to that point where we no longer have to deal with fractions. Okay? So let's look at example 1. There's two different options here that we can go. In this example, the first one is we're going to do the most common one and solve by using the least common denominator. And the second one, we're going to solve by using proportions. Okay. So looking at number 1, the least common denominator between all three of those terms, remember this is just 6 over 1. Okay, the least common denominator is going to be, right, 3 in one of them, the other one's x plus 3, and the other one's just 1. So 3 times the quantity x plus 3 is your least common denominator. Okay? So what we're going to do is I'm going to rewrite it out, okay, just so we can see below here a little bit easier. And that's going to equal 6. Okay? And what we're going to do is we're going to multiply times everything times 3 times the quantity x plus 3. So 3 times x plus 3 here, times 3 times x plus 3 for the second term, and then don't forget about the 6 on the other side of my equation. Now this is going to work out pretty nice, right? The reason why we're multiplying times that least common denominator is so we can get things to cancel out, especially the denominators. So my x plus 3's cancel out. I'm left with 3 times 10. Okay, my 3's cancel out. I'm going to be left with 10 times the quantity x plus 3. And then nothing's going to cancel out here, but 6 times 3 is 18. And then we're going to take that times all of x plus 3. So now we no longer have to deal with a fraction. Okay? And now all I can do here is solve for x, right? Distribute in both of these. We're going to get 10x plus 30 equals 18x plus 54. And then we're going to solve from there. Okay, subtract 54 from both sides. Right, and then subtract 10x from both sides. Okay, and we'll get 6 equals 8x. So x is 6/8, which simplifies to 3/4. Okay? So that is one way that we can solve it, right? We can use that least common denominator. But sometimes, you know, if we only have x in, or our variable in one of the denominators, we might be able to isolate that rational term. So let me rewrite it in this one here. Okay, so we're going to rewrite it as, off to the side, 10 over x plus 3 equals 10 over 3, sorry, not equals, plus 10 over 3 equals 6. And I'm going to write this as 6 over 1, okay, just as a reminder. Okay, I want to get rid of that 10/3, so I'm going to subtract it from both sides. And in order to add or subtract fractions, we have to have the same denominator. So we're at this point right here. So this is a good reminder. Multiply numerator and denominator by 3. So we get 18/3 now. Rewrite that 6 as 18/3. Subtract 10/3, and we're going to be left with 8/3. So here's where we are. Okay? We're at 10 over x plus 3 equals 8/3. So what we have here is we have that proportion. Okay? We have our proportion here. And the only way to solve for that proportion, remember, is to cross multiply. Okay, so we're going to multiply these two and multiply these two. So we're going to get 8 times the quantity x plus 3 equals 30. And the reason why I wrote that out right away was to remind ourselves that we actually have to distribute the 8. So 8x plus 24 equals 30. Subtract 24 from both sides, you get 8x equals 6. So once again, when you divide both sides by 8, you get 6/8, which is going to simplify to 3/4. Okay? All right, so sometimes it'll work out like that, sometimes not so much. Okay, but let's see what happens if we try another example here. Okay, so let's go to example number 2. Okay, number 2 here, there's definitely some multiple ways that we can solve for this. Okay, and I'm going to start out with what I think is the easiest in my mind here, and that is trying to solve it using the least common denominator. So when I look at all these, you know, there's only, you know, the least common denominator, you know, our denominators are x, and technically 1, so it's got to be just x. So multiply everything times x here, and we actually see our x's are going to cancel out. They're going to cancel out, and we're going to be left with 2 plus 1 equals 3 times x. So we get 3 equals 3x, and so therefore x must be 1. Okay? So you could go that route. We can go that route, or what somebody mentioned to me earlier as a good reminder is, you know, these two have the exact same denominator, right? They both have a denominator of x. So whenever anything has the same denominator, what we can do is we can add the numerators together. So this can be rewritten as 3 over x equals 3. And you can multiply both sides by x, right? Or you can just realize that the only way any number, okay, if I take 3 divided by any number and I get 3, maybe off the top of my head, I already know that it's 1. Okay? But there's more than one way, all right? So that one wasn't too bad, right? Number 2 is not too bad at all. Okay, pretty simple. 3, however, is going to require a little bit of work. Okay? Find that least common denominator right away. Okay, so I only look at my two denominators here, x and 6. Okay, I'm not even worried about, you know, just a whole number here, or just an x over 1. So my least common denominator is 6x. So I'm going to multiply everything times 6x to begin with. Okay, and let's cancel out what we see here. 6x times x actually is going to give me a 6x squared. And my x's are going to cancel out in the second term, so I'm going to be left with just 6 times 4, which is 24. And then my 6's are going to cancel out in the third term there, and I'm going to be left with 25 times x. Okay? So no more fractions. But what I see is that I have a quadratic here. So in order to solve for a quadratic, we need to set it equal to 0. So we're going to get 6x squared minus 25x plus 24 equals 0. And then you guys have learned multiple ways to solve for quadratics here, you know, in the past. And now you guys can choose any way that you would like, right? So like maybe I would suggest, you know, if you can do AC method, that's great. And if you feel like you can't do the AC method, you always have the quadratic formula, right? You can use that quadratic formula if it's in that standard form to help set up and find your solution or solutions, all right? I'm going to use AC method because, you know, we haven't used that one in a while, just to see. So I take A times C, right, 6 times 24, and I got the factors of 144 that add up to a 25 are actually 9 and 16. Okay, so what I can do here, if I use the AC method, is we can factor by grouping. So I'm going to get 6x squared minus 9x minus 16x plus 24. Okay, so all we did was break up that middle term, right? And now I'm going to group them, the first two and the last two. And we're going to take out the greatest common factors. So greatest common factor between 6x squared and 9x is a 3x. And anytime you can pull out a negative, we're going to pull it out. So we're going to pull out a negative 8. That's the greatest common factor between negative 16x and 24. And we're going to be left with 2x minus 3. Okay, now remember this is equal to, we got to set this equal to 0. Okay, so I'm at this point. And I notice once again, okay, we got the same thing in each parentheses. So we're going to bring our GCFs together. And, okay, I have my two factors. And now we set each factor equal to 0 and then solve. Okay, so x equals a positive 8/3 or a positive 3/2. Okay? Okay, so one last example here of just solving for these rational expressions. Biggest thing, always make sure that your denominators are completely factored. Okay, so when I look at x squared minus 9, all right, we can rewrite that as 10 over x plus 3 times x minus 3. Okay, difference of perfect squares. So 5 over x plus 3, can't simplify that anymore, or factor it, I should say. And can't factor 1 over x minus 3. So those are my three terms, completely factored. And now our least common denominator, notice how x plus 3 is in 1 in the second term, right? X minus 3 is in the third term, but the first term has both of them. So we're going to have to multiply everything by x plus 3 times x minus 3. All right? So let's multiply x plus 3 times x minus 3, x plus 3 times x minus 3, and the same thing to the last one. Okay. All right, so let's look here. X plus 3s are going to cancel out along with x minus 3s, so I'm going to be left with 10. Okay, x plus 3s are going to cancel out here. I'm going to be left with 5 times the quantity x minus 3. And then the last one, we're going to be left with 1 times x plus 3, right? Just whatever's in the numerator, which is just x plus 3. But now we got rid of that, and we can now solve. So we get 10 plus 5x minus 15 equals x plus 3. Okay, so now what we're doing is we're just solving a regular equation here. Combine your like terms. Okay, maybe add 5 to both sides to get 5x equals x plus 8. And then subtract x from both sides to get 4x equals 8. So therefore, we're going to get x is equal to a positive 2. Okay, so all we're doing here is you have to identify, right, like step 1, what is the least common denominator? 2, multiply everything by the least common denominator, and then solve. Okay, so those are kind of basically your 3 main steps. Okay, and it all comes down to identifying what that least common denominator is, right? And maybe even before that, making sure is everything completely factored first? Is everything completely factored? Once you can, then you can identify what the least common denominator is. All right, but let's look at some real world applications here. How does it apply to the real world? Okay. All right, so basically in the first example here, we're just comparing the rate of Grace and the rate of Brecken on how fast they can cut or mow the lawn. And then we're going to see if there's a way that we can determine how long is it going to take for both of them to cut that lawn. So let's take a look at number 1. All right, both of them are trying to make money for the summer. Grace, we're told, can cut Mrs. Bauman's yard in 2 hours. And then Brecken can cut Mrs. Bauman's yard in 3 hours because she's using a self-propelled mower. We want to know if they work together, right? What is their combined rate going to be, and how long is it going to take? Okay, so we're going to let t equal the number of hours it's going to take together. So number of hours together. Okay. The rate in this situation is the yard per hour. Well, they're only mowing 1 yard. Okay, or 1 lawn. So for them, or for Grace to mow 1 yard, okay, or this yard, it could be Mrs. Bauman's yard, but for her to mow 1 yard, it's going to take her 2 hours. Okay, Brecken is the same yard, so it's still 1 yard, but it's going to take her 3 hours. Okay, so we have our rates, and we need to understand that the word together means, okay, them added together. Okay, so we think of it as this. Right, I'm just going to rewrite below here. Okay, 1 yard over 2 hours. Okay, plus 1 yard over 3 hours has to equal that same yard over t hours. Okay, so what am I saying here? Okay, remember this is Grace's rate. Okay, we're adding it with Brecken's rate. Okay, and when we add those two rates together, we should be able to find their combined rate. That's what we're trying to figure out, is what is their combined rate. Okay, so let's drop all the units here. Okay, so let's rewrite this as 1 over 2 plus 1 over 3 equals 1 over t. Okay, so 1/2 plus 1/3 equals 1 over whatever t is. Okay, so at this moment in time, right, we need to determine what the least common denominator is, once again. Okay, all of my denominators are 2, 3, and t, so I'm going to multiply all those to get 6t. Okay, that's our least common denominator here. Okay, so I'm going to multiply everything there times 6t. So times 6t times 6t times 6t. Okay, my 2 and 6 are going to cancel out. I'll be left with 3. So 3t plus 3 and 6 cancel out to give me 2 plus 2t equals, and my t's cancel out on the right. 6 times 1 is 6. So 3t plus 2t equals 6. So 5t equals 6, which means that t is going to equal 1.2 when I divide everything on both sides by 5. Okay, so what does that mean? All right, what we're saying is that it will take Grace and Brecken 1.2 hours, right, or 1 hour, 12 minutes to mow the lawn together. Okay, it's going to take them a little over an hour, which if I stop and think about that for a minute, that makes a lot of sense because, you know, Grace mowed it faster than Brecken, right? Grace did it in 2 hours, Brecken did it in 3. So with them coming together, it should be less than 2 hours, right? It should be quicker, okay? So in example 1, we were given the rate of both people and found their combined rate. In example 2, though, we're going to be given what the combined rate is, and then we're going to determine what each individual rate is for the job. Okay? So we have Jacob and we have Matt, his apprentice. Jacob is 4 times faster, okay, than his apprentice. They are refinishing a 100 square foot piece of flooring, and they can finish it in 3 hours. All right? So we're still going to approach this the exact same. We're going to have Jacob's rate plus Matt's rate has to equal their combined rate. Okay? So let's stop and think about this for a minute. We're going to let T equal Jacob's time to finish 100 square feet. Okay? So if T represents the amount of time Jacob is going to be able to get this done, then we know that we can express Matt's time in terms of T. It's going to take him 4 times longer. So we're going to write it as 4T. All right, so let's fill it in here. Jacob's rate, right? He can do 100 square feet for however many hours, right? Matt's rate, he can do 100 square feet in, 4T, right? 4 times the amount of hours, right? And then their combined rate, remember, they finished 100 square foot area in in 3 hours. Okay, so we actually know what the combined rate is this time. Okay, so let's remove all those units and let's try and solve here. Okay, so we got 100 over t plus 100 over 4t equals 100 over 3. So we look for that least common denominator, right? We have t, we have 4t, and we have 3. So we know we're going to at least have to have a t there. And the least common multiple between 4 and 3 is 12. So let's multiply everything times 12t. Okay? So my t's are going to cancel out. I get 12 times 100. Okay? T's are going to cancel out again here, and 4 and 12 simplify to 3. So 3 times 100. And then 3 and 12 simplify to 4, and we have 4t times 100 on the right side of my equation. Okay? So now I got rid of all of that, all those fractions. 1200, let's solve. Plus 300 equals 400t. So 1500 equals 400t. And divide that, we get 3.75 for t. Okay, so once again, we got to interpret what that means. Okay, so we're going to say Jacob can complete 100 square feet in 3.75 hours, okay, or 3 hours and 45 minutes. But Matthew, or Matt, can complete 100 square feet in 15 hours. Okay, so it's going to take him longer. Remember, it's going to take him exactly 4 times longer. So how did I find that 15? Remember, Matt was 4 times the amount that Jacob was. So 4 times t, or 4 times 3.75, gives me 15 hours. Okay?